We trust our eyes above all else. If we can see a thing, we confirm it is real. If we can't, our instinct is to demand proof. Yet some of the most overwhelming physical forces on Earth, the currents that dictate global weather patterns and erode mountains over time, completely bypass this biological hardware. They are completely invisible. In the late 19th century, the poet Christina Rossetti distilled this problem down to a single childlike question: who has seen the wind? Her immediate answer, neither I nor you, is a simple admission of our shared biological blind spot. We lack the visual equipment to perceive it directly. To study a phenomenon we cannot observe, we have to change our approach entirely. We have to stop searching for the entity itself and start measuring the physical footprints it leaves on the things we can see. Rossetti's poem actually provides a manual for this exact kind of observation, starting with what we can call microevidence. She writes, "But when the leaves hang trembling, the wind is passing through. A single vibrating leaf is our smallest baseline unit of proof. Look at the chaos in suspended dry autumn leaves. Their erratic, rapid movement maps exactly how lower air currents are twisting across the ground level. But a slight breeze is easy to ignore. To measure severe power, the poem structuralizes an escalation of physical proof in its second stanza. This illustrated edition serves as our primary case study. It pairs the full text directly with a visual record of an escalating storm. The language shifts abruptly. We move past trembling leaves to heavy, rigid trees forced to bow down their heads. The artwork immediately reflects this massive force. Heavy pine branches are stripped back horizontally, thick trunks pushed out of alignment. We have photographic records of this kind of structural yielding during severe hurricanes, where the dense wood of palm trunks is forced into extreme curvature. Moving from the nervous rustle of tiny leaves to the aggressive bending of heavy wood gives us a scale of force. The larger the mass forced to yield, the more kinetic energy we can attribute to the air current passing over it. There is one final, critical tier of evidence in this progression, moving away from plant life to focus strictly on human friction. At the bottom of the painted path, we find a solitary traveler fighting the conditions. Notice her severe forward tilt to maintain balance. The sweeping lines of tall grass act as a solid barrier, pushing back against her progress. We match this illustrated posture with historical photos of people fighting atmospheric displacement. Bracing against a tree to stay upright requires massive energy transfer. By tracking the physical toll on a human body, an abstract atmospheric anomaly is translated into a tangible, highly measurable threat. We return to Rossetti's opening question: who has seen the wind? The literal answer remains definitively no one, but science provides a tool to bypass that sensory limit: inference. By carefully mapping our specific data points, the vibrating leaf, the bending pine, the struggling traveler, we effectively triangulate the shape, direction, and velocity of the empty space between them. We can reclassify that painted landscape as a visual record of the wind's trajectory. Acknowledging our blindness is what ultimately allows us to gather undeniable proof through secondary observation. True comprehension of the physical world doesn't always come from direct line of sight. Sometimes we just have to look past the empty space and rigorously observe the impact the invisible leaves behind.